Welcome everyone to the 12th video in a series of videos on solar and wind energy estimation and forecasting application developed in MATLAB. I'm Kiran Gaikwad, the developer of the application. I have a Masters of Technology in Power Electronics and Power Systems from Sardar Patel College of Engineering, Mumbai. I'm currently working as a Junior Project Fellow at GERMI, Gujarat Energy Research and Management Institute, under Dr. Sagar Kumar Agrawal. In this video, we will have a demo on the wind energy estimation app using wind and temperature files from the user. As we have seen from the last videos, that the wind energy estimation app is a sub-app of the wind energy application. So we can maneuver to the wind energy estimation application from this window by pressing this button, or as we have seen in the previous video, that this is the wind turbine data acquisition app where the user inputs the information about the wind turbines which are present in the wind power plant, and this data is actually carried forward to the wind energy estimation app where the actual energy estimation simulation happens. So we can even go to the next application, that is the energy estimation application, by pressing the next tab. I have opened the wind energy estimation app, which looks like this, beforehand to save us some time, and this is how the wind energy estimation app looks like. And we will do the energy estimation stepwise. So the first step is the site data. So we have to input some site data. So our project name is wind plant. Plant capacity is 138 megawatts, but we have to write it in kilowatts. Latitude and longitude of the location of the wind plant and the altitude of the location of the wind plant. This is the data required, the site data required for the simulations. The step 2 is the number of days for simulation, or the simulation period data. So over here I have inputted year as 2015, and it is a non-leap year, and I have selected the simulation period to be the entire year from January 1st to December 31st, but the user has the privilege to change this by using the drop down menus like this. For our demonstration purposes, we will use the entire duration of the year, that is of the year 2015. And the third step is the computation options and better data pane, and here we can see we have to enter the simulation resolution in minutes, and I have entered it as 60, so that is 1 hour resolution for our simulation. So what this means is that I have temperature and wind speed files which have a resolution of 1 hour. Okay, so let us have a look at the temperature and wind speed files which are present over here. Yes, so this is the wind speed file. It's just a column of data which is present in our Excel sheet, and it is the hourly data. If we have a look at the downside, we will have 8,760 rows of data present, as that is the number of total hours in a particular year, with 365 days as the day numbers. And okay, so similarly we have the temperature data over here, same 8,760 rows of data over here for that particular location, and that's about it for the data. And as we have seen in the last video, that we can, if we don't have those files, we can use the Webull distribution, but we are having the weather data files, so we'll be using this option, and as we can see, all these buttons get enabled after that. So let us input some temperature data for the location. So this window pops up and we have to find our file and load it in, and it is somewhere over here. Yes, wind plant weather file, and this is a temperature file, a non-leap year. Okay, wind speed file. It's the same location. Is the wind speed? Yes, wind speed. Open. Okay. So the next step, as we have now input temperature and wind speed Excel files into the application, we have entered the site data and the simulation period data. We can go for step 4, that is loss parameters. And this is quite an interesting window actually. We will go in detail when our simulation starts, but for this demonstration purposes, you can see we have two options to define all the parameters, control parameters as per our requirements, or use the default values over here. So for our demo, we will be using the default values, and we just have to click OK. And we should not close this window till the simulation completes. So let us just minimize this now, and we can start the simulation and wait for a particular period of time. And let us start to understand this loss parameters window if we can. Here, guess person simulation. So what we are expecting after the simulation are some Excel files where all our values which would be computed would be stored, and they are something like this. We will have 3 Excel sheets, wind turbine plant for each of the wind type. So we will have 3 into 4, that is 12 Excel files, and I'm trying to show you how they would look. So we will have 3 files per turbine type, one for the daily file, that is day-wise aggregation of energy, then the intraday file, that is the hourly or the resolution, simulation resolution wise storage of the computed values, and then the monthly file. Okay, so we have all those files over here, and every file would consist of, let us check out it in the monthly file. And so how many months is that? And this is something which is odd that I have to correct. And what it means is that this thing is WTG out, that is the wind turbine generator energy output, and this is the energy or the power supplied to the grid, and this is the ohmic loss, and this is the transformer loss. Okay, all are in watts, and different sheets correspond to the different sub models like this, and this is just skewed over here, so it's over here. So as we know from the data sheet, from the data acquisition, that for type 4 of our wind turbine we had 4 submodels. So every submodel occupies one sheet inside that particular Excel sheet. It is similar for on the different 2 resolutions, that is in intraday, where we have 4 sheets again. Okay. And columns remain the same, only like over here in the intraday one we have day, month, year and time, whereas in the daily resolution one we have day, month and year, and over here we have month and year, that is the monthly thing. So this is what you will expect. You will have these kinds of Excel sheets created for you once the simulation is done. So let us go back to the simulation. It takes some time. It's quite a lot. Like most of the time is taken in creating those Excel files rather than the computations, but it's useful to have the Excel files. So all these files have been created. So now we're looking at like the last type is going on. We have intraday, wind turbine plant. We have 3 files for type 1, 3 files for type 2, 3 files for type 3, and 1 file for type 4. So it is computing and storing it in the Excel files. So more two files to go, and then we will have a report window popping up. But it will have to take some time. Okay, we are at 3 files for the type 4. So all 12 files are ready over here for the fresh simulation that we have done. And wait over here for the report window to pop up. It takes some time. It will happen. Okay, so we are done with the simulation. And this is like, if you have seen the previous videos, the appearance of this window must be familiar to the simulation report of the solar energy report window. So over here we have the project details, and over here we have the total energy at different points, like the WTG output and the energy to grid in kilowatt hours, and total losses over here is ohmic loss and transformer loss over the entire simulation period in kilowatt hours. Then over here we have a table. Okay, so this is not optimized for, this is having all the columns even for which were actually related to the solar energy app. So we will get it edited in the next version, but the main things over here are this table. Over here the columns, the rows correspond to the months, and each column is a particular variable, and that is PV of the time. Okay, we have to change it all, but this one means this is the WTG output, this is the energy to the grid, this is the ohmic loss, and this is the transformer loss. These are the same things which we saw previously on the Excel files. Okay, and as you may see, there is not much variation in monthly data plotted over here. We can, this is like the month-wide energy output from the wind turbine, so at least this is showing something proper. I'll have to change these headings over here, which will be done in the next version. Press next. I am getting month-wise energy output to grid. Okay, that's good. And again next, and I have month-wise ohmic losses. I was not it like the graphs move from one column to the other, from left to right. Keep on pressing next, and you have transformer loss, and then it will again go backwards. If you press previous, you will have this. So it's quite interactive as of such, and okay, this has to be changed. No problem. So we have seen the output simulation report. Now we can just close this and we can concentrate on our loss parameters window. So it's quite interesting. Like there are two options, like you can either use default values or you can use user defined values clicking this. The first thing is STC for power curve generation. So usually the turbine manufacturers provide the power curve at their testing facilities are at 0 meters, like it is at sea level. The pressure over there is maintained at 1 atmosphere, and air temperature is 15 degrees Celsius, for which the air density we get is 1.225. But if we want to customize this, or maybe there is some vendor who is not using this standard testing conditions, maybe 0.8 somewhere due to the height, that is 100 meters maybe, so we can compute and use this air density to correct our power. This is used for power correction, and there are electrical losses which we can mention in percentages, the ohmic loss and transformer loss. Then there is the wake loss, the loss due to wake effect, and we have two options. Either we can go directly for the simple percentage, now in this case it is 5, or we can use a wake model and we can select this option and then press this button. We will enter into the new window of wake effect models. So we have two models over here, that is the Jensen and the Franson model. These models were selected because of their ease of computation and the minimum requirement of inputs from the user. And we have some data populated over here for the users so that the users have some reference for them, and this can be used. Now we know that we have wake effect models built into the system, and then there is performance ratio, and this is actually the case when, like, even if you have 100 wind turbines in your plant, it will not be the case that all wind turbines work all the time. So there would be some average numbers, like, hence we have to account even that loss of energy. So the performance ratio is the fraction of the total number of turbines which would be active all the time. Okay, otherwise this is for an approximate estimation, but if you have active turbine files, then you can have this. You can select this and then given the Excel files which tell how many numbers of turbines of each class were active at this particular time period. If we have been using PR, hopefully this would be helpful in the future when we have that much amount of data. Okay, and the next thing is the loss parameters over here. This is for hub height correction, and this table shows you the terrain characteristics and the friction coefficient associated with them. We have this, and then you can select which kind of a terrain characteristic your plant lies on, and the corresponding terrain coefficient, and the height of anemometer, that is where your anemometer is placed to measure the wind speed so that the hub height correction can take place. Okay, so there are many options over here which you can tweak and control your wind energy estimation more accurately. That's all for the video, and hence you can see that this application is useful for estimating energy of a grid connected wind turbine plant. It can work on any sub-hourly resolution weather data files. Moreover, all outputs are stored into Excel files which have energy computations at every level in sub-hourly, daily, and monthly resolution. Thank you.